All right, guys. Well, I've got us about 2 minutes after the hour here, so I think we can get started with our equipment qualification webinar. We've got well over 30 attendees joined in so far. We had about 80 people register for this webinar, so I'll expect we'll get some more on as maybe they jump off of other calls that ran a little bit late. We know how that goes during our pandemic times. All of us are on calls a lot. So first of all, I want to thank all of you for joining us, taking a little time out of your day to learn a little more about equipment qualification and a little more about what Paragon does. We've got a really good presentation for you today, and the majority of it's going to be given by one of our environmental qualification engineers, Ross Loberbaum, and he's a mechanical engineer from North Carolina State University. And he's been with us for about 10 years. And started his career doing environmental qualification and enjoys it so much he's continued to do it, and we appreciate that a lot. So Ross is going to give the majority of the presentation, and then John and myself will be here to support him on any questions you guys have when we go into the question and answer period. So Ross, let's go to the next slide. Just a couple of quick housekeeping notes that we do for all of our webinars. We're going to keep everybody on mute for the duration. That just helps us, make sure we don't have any noise, kids screaming in the background because they can't go to school, or dogs barking and various things. We know all that's happening, but we'll do our best to keep it cut down to a minimum. We do have a QA button. So if you look there at the bottom of your Zoom call, you'll see a question and answer button. You can use that to ask questions, and you don't have to wait till the end of the webinar to do that. You can ask questions throughout. They'll go into a queue, and we'll be able to answer them when we get to the end. So as you think of them, just type them in, and we'll make sure they're saved. And Ross and John and myself will do our best to answer them. Like we've been talking about a little bit, this webinar is being recorded. So it'll be recorded, and it'll be put on our YouTube channel. And as that goes out and becomes a live YouTube video, we'll be sending that link to you guys so that you can share it with anybody that you could benefit from this content. So Ross, let's take a look at the agenda. So today we'll be covering a very detailed presentation on equipment qualification. So Ross is going to give us a good overview. He's going to look at seismic qualification and harsh qualification, lead into some of our experience with EMC and software V&V, and most importantly for all of you guys is to talk about our EQ experience, the lessons learned, and some key takeaways. So with each one of these slides, we're going to be talking about in particular the lessons learned and things that are going to be specific for you guys at nuclear power plants, at new facilities, at SMRs, all the places where we've got people calling in from. What are some lessons that we've learned that will help you improve your procurement, improve your engineering specifications, and make sure that you're able to get the help you need when it comes to equipment qualification. So with that, I'm going to turn things over to Ross here, and he's going to walk us through the details in ways that I would not be able to. So Ross, let's get started, man.
Great. Thank you so much for the introduction, Ty. Again, my name is Ross Loberbaum. I'm the lead EQ engineer here at the Paragon, Texas facility. I'm extremely excited to be talking to you today about equipment qualification. It's one of my main passions within the industry, and it really speaks volumes to the extent that we go to maintain the elevated level of safety that not only our industry demands, but we demand for it. So to really kick things off and to get started, I wanted to first start with what is equipment qualification. Let's put a definition to that. I have the formal definition here. In its most basic form, equipment qualification is the methodology we utilize to provide the necessary assurance that a piece of equipment is going to maintain its safety function even throughout the most severe environmental conditions associated with the installed application. So throughout the industry, we're going to be looking at things like evaluation, testing, analysis to be able to combine and envelope the combined effect of normal, abnormal, and postulated design basis events. So whenever you're looking at equipment qualification, it's extremely important that one of the first steps is you're going to categorize the type of environment your equipment is installed within. And those two categories are going to fall within either mild or harsh environment applications. So really, to kick things off with that, it's important to differentiate between the two. Now, this is the definition straight out of our domestic industry standard IEEE 323. It's applicable throughout the industry. A mild environment is defined as one that would at no time be significantly more severe than normal plant operation. So you're looking at all the conditions associated with your installed application, whether it be temperature, humidity, pressure, radiation, accident conditions. You're going to be looking at all those parameters, comparing them to your normal plant operating parameters, and seeing if there's any elevated attributes that would dictate it falls outside the scope of a mild environment application. Now, on the flip side of that, if we're talking about harsh environment, you're looking at any elevated parameter that's significantly above what your plant's going to experience for the intended application. So you're going to go through all the parameters associated with that, categorize where your equipment falls, and you're going to work with your vendor to be able to establish a program or traceability evaluation to get you a qualified piece of equipment suitable for your application. Now, I wanted to provide this slide as an overview and somewhat of a bird's eye view of what's going to be happening behind the scenes whenever your vendor is going through a qualification program, whether it be for mild environment, seismic only, harsh environment. Now, this was developed for our commercial fleets. For all of you small modular reactor folks or micro reactor folks, we're gearing up our program to be able to utilize the same methodologies we're going to discuss herein and apply them to be able to envelope your application requirements. So as we're going through here, there's a lot of value for a broad spectrum of applications. So we'll discuss some of that moving forward in the following slides. I wanted to kind of break down what's happening to distinguish between mild and harsh environments. If you're working with a vendor and you determine that you're going to need mild environment qualification, you're going to be looking at that vendor preparing a qualification plan, dictating all of your application specific requirements, procuring test specimens, receiving test specimens, and kicking off testing with baseline functional testing, seismic, and your final BFT. We're going to define what each of these steps mean in a slide to follow. Now, moving on to harsh environment, you're going to incorporate the same methodology of sequential testing. Once you get your plan, you have your test specimens. Two bullets here that I really want to place priority on and I really want to discuss in a bit of detail is going to be your material analysis and heat rise testing for your test specimen that you're going to be qualifying. Those two bullets play directly into your thermal agent calculation, which dictates in a lot of times the majority of your qualification schedule and what you can expect as a lead time to meet your critical install date. So we're going to go through those activities. Again, a baseline functional test is performed prior to and after each qualification activity. So to continue with the harsh qualification program, you're going to be performing your aging operations, which includes thermal, radiation, mechanical, electrical cycling. You'll be doing your seismic testing, and you'll be performing as the final step, accident testing, followed by your final BFT. So all of that is utilized as input to provide justification that your equipment is suitable for your environment. Now, as we go through the following slides, it's important to note that for typical applications, these tests are going to be performed in chronological order. It's an order of operations dictated by our industry standards. It's what your vendor is going to be going through throughout the qualification program. So the slides are following that suit throughout both of these programs and the associated methodologies. To start, let's define what baseline functional testing is. It's an extremely critical step in your qualification program. It documents the performance of your equipment prior to and after being exposed to each environmental test, which has huge value add in determining whether or not your equipment is going to be acceptable for its intended application. So you're verifying that it meets both passive and active safety function requirements as it relates to the qualification activities you're performing. You're establishing pre-tested conditions and functionality of the test specimen at the very beginning of the program as your main baseline to be able to establish acceptable results. And it documents the impact of each qualification step as compared to the previous step and all the way back to the first step in any given qualification program. So some important things to highlight here are the lessons learned I have notated. Whenever you're doing a qualification program, it's critical and always best practice to minimize test specimen setting adjustments, and that's directly related to avoiding potential failure mechanisms that are not representative of what's going to be happening in the plant. If you have a pressure switch, it's going to be set at 20 psi. It's important to take into account adjustments made and the adjustments required for baseline functional testing while avoiding inducing a failure that's not required. So you always want to look at adjustments required. Let's simulate the installed application. Let's avoid failures. And something that goes along with that, required handling and transport of the test specimen. After each step, obviously each testing step is performed in a different location, whether it's in-house, third-party facility. It's always best practice to be having the correct procedures and processes to handle and transport the test specimen without inducing any potential failures or impact to the test specimen that would degrade the performance and impact a successful qualification. So it's important to think about those two attributes whenever you're going through baseline functional testing, especially, and throughout the rest of your qualification program. Now, if we're talking about a mild environment, if you think back to that process map, you're going to be doing a pre and post baseline functional test with seismic testing in the middle. And so some things to think about with seismic testing is you're going to have to know the associated required response spectra, RRS, for the installed location. And I have some general guidelines here for different types of equipment, mounting configuration, and what's going to be applicable to give your vendor to make sure they're enveloping your requirements accordingly. If you're mounting equipment to a floor or skid, you're going to be using the plant floor RRS in that location. If you're mounting a wall-mounted transmitter or similar equipment, you're going to be using the RRS above the floor of the wall it's mounted to. If you're mounting inside of a panel, cabinet rack, any sort of structure that has in-panel response spectra, this is where it kind of comes to a fork in the road. If you're going to be testing equipment inside the structure it's going to be installed within, then you'll test to the floor RRS at that location. If you're testing a piece of equipment that's installed inside a structure where there's going to be in-panel response, you're going to need to use previous TRS for that in-panel as your required response spectra, or you're going to have to procure and test inside the larger structure to simulate the appropriate response. And then the last category here, for all of your valves, actuators, anything that's pipe or duct mounted, you're going to be looking at performing rim testing per the appropriate standards. And you can work with your vendor to make sure you have the applicable testing requirements to make sure that you're enveloping that appropriately. And so getting into the testing activities that are going to occur throughout that program, number one, resonance search. It's important to know if you need resonance search information, if that's going to be beneficial to you. A lot of times with larger equipment, it's fairly common within the industry to not envelope a given profile below 3.5 hertz due to table limitations. And depending on your industry guidelines and standards, there's justifications that can be provided for that, given there's no resonant frequencies for your equipment below 5 hertz. So if you have a large structure and it looks like it might be susceptible to resonant frequencies in the low frequency range, resonance search can be extremely beneficial in providing the justification you need to be able to write off that phenomena and obtain a successful qualification. If you have vibration aging or vibration activity in the installed application, we're going to simulate vibration testing during the qualification program. And then depending on your mounting type, we're going to either perform multi-frequency or required input motion testing to envelope both OBE and SSE conditions, OBE being operating basis earthquake and SSE being safety shutdown earthquake, or DBE for you Canadian folks. Now, over off to the right, I have a standard multi-frequency response spectra. This comes straight out of C3798. You can see your peak acceleration there at 4 hertz, your 0 period acceleration, 33 hertz and beyond. And you're going to give a similar type of input for multi-frequency testing to your vendor to be able to get an output similar to the below figure, showing that your testing facility has enveloped to the requirement and provided the necessary assurance that the equipment functioned and maintained structural integrity as necessary. So those are some of the things that you can be looking for whenever you're performing seismic testing. Here at our Paragon testing facility, I actually have notated the 4 tables that we have in-house. We utilize these to meet any and all industry requirements that we have come through our facility, 2 of which are biaxial, the other 2 are triaxial to meet industry requirements. The main intent and the main information I wanted to drive off of this slide, however, is the lessons learned. There's some very critical operations that can be performed to help mitigate failures and to maintain schedule whenever you're going through seismic testing in a qualification program. Number 1, evaluate the equipment for seismic durability prior to selection testing. There's a lot of industry experience and there's a lot of evaluation that can be performed up front prior to going down the road of testing to provide some assurance that you have a piece of equipment that has a good chance of possessing the seismic durability required to meet your application requirements. So work with a vendor, ask your vendor the question, what type of evaluation is done up front? Is this look suitable for the acceleration and profile requirements for our application? Go through that process on the front end to help save you some time. Perform modifications up front to increase structural integrity, especially for large structures containing sheet metal design, sheet metal construction, anything that could benefit from gussets, additional structural members. It can go a long way in giving you the structural rigidity you need to get a successfully qualified item. And if those modifications are looked at and performed up front, it can go a long way in saving you time and cost on having a failure that has to be remedied after the fact. If you are performing testing in a structure, this is a big one. If you're going to be testing, whether it be MCC cubicle, some type of cabinet, large structure with in-panel response spectra, it's extremely beneficial to utilize multiple accelerometers during their original testing so you have that in-panel response for use on future procurement activities. If you have that TRS from the original testing, if you need to replace a component, get something different installed, you can actually take that new piece of equipment by itself, mount it on a fixture, and use the in-panel spectra to test to rather than having to procure and test an entire new structure that's going to add excess cost and lead time. So it's definitely something to look into if you're performing a large structure seismic qualification. Make sure your vendor is utilizing accelerometers to capture that in-panel. Following seismic qualification, this is where we step into harsh qualification requirements. And the first step of many harsh qualification is always going to be your aging, including thermal, radiation, mechanical, electrical cycling. Thermal aging, and I have it highlighted here, is the largest determinant of your qualification program schedule, and it is oftentimes unknown at the beginning of the RFQ process all the way until receipt of the equipment by your vendor has been made and initial testing has been performed. So we'll get into a little bit why that is here on this slide. But thermal aging is a really intricate process, and that you're taking the qualified life that you need in the plant, whether it be 20 years, whether it be 40 years, and you're actually compressing that down and performing an accelerated aging program to simulate that in full installed life to get an end-of-life condition for your equipment. And the way that's done is typically through use of the Arrhenius methodology. So if you look at this equation I have here, this is the Arrhenius equation. This is what your vendor is typically going to be using to define and establish how long your equipment is going to need to be in an oven to simulate the full life. So if you go through the parameters here, the aging temperature, that's the vendor's oven temperature they're going to age your equipment at. Component temperature, that's your worst case or average plant temperature, including temperature rise due to energization and in-panel temperature rise. Your qualified life is the output that you're looking for. And the molecular activation energy is selected based upon all of the non-metallic materials within your component, which we're going to discuss here. So the 2 operations that need to happen prior to establishing a harsh qualified schedule is you're going to have to receive the material and you have to perform destructive heat rise testing and non-metallic material verification. Something that's important to note here is that whenever you perform heat rise, it's extremely beneficial and fairly unique within the industry to verify that heat rise, not only at the hotspot locations within your equipment, but also at the non-hotspot locations. And the reason I say that is because when you take that test specimen, You break down all the non-metallic materials in there to perform this Arrhenius methodology. You're going to pair those non-metallic material activation energies with the heat rise associated for the exact location that's installed in your equipment to be able to develop your aging time. So that can remove a lot of lead time, and more importantly, it can remove excess conservatism that could potentially lead to a failure that is not indicative of what needed to be performed. So performing those two steps is extremely critical. It drives your schedule and it avoids failures by defining and aging your specimen appropriately. Thermal aging activities that could benefit procurement needs. And this is some things to think about whenever you're thinking about schedule and harsh qualification needs within your plant. If you're in a bind for a harsh qualified item, talk to your vendor and work with your vendor. Ask about parallel aging programs. Something that we do quite often whenever we have a client in the industry in this position is if they're looking for a 20-year qualified life on a piece of equipment and they're in a bind, the schedule is going to be longer to meet their critical install date, we can actually run parallel aging programs with multiple test specimens for a lesser qualified life. So if you're looking for 20 years, we'll run a program at 5 years, go through the testing, generate a qualification report, get you the equipment you need so you can meet your critical install date, and we'll have those backup specimens running at a longer qualified life, and we'll give you that extension after you've met your critical dates. So that's a way where you can get your full qualified life, you can meet your install, and it's a win for everybody. So work with your vendor, see if that's an option for you. And then also, if you're in a similar position, see if the qualified life of your component or assembly can be extended through evaluation. And this is certainly something you can work with your vendor on. If you have a piece of equipment that's at the end of its qualified life, there are certainly variables that can be looked at to potentially extend the acceptable life of that equipment to give you some more time. And one of the main things you look at is what we just discussed with the thermal aging methodology using the Arrhenius equation. For example, if that equation was performed using a temperature of 104 degrees F for your plant installed application, and you look back and the temperature was closer to 85 degrees average, you can actually back calculate that methodology to give you an updated qualified life for extension to give you some more time to get new equipment installed. So it's of huge value, and it can be done readily with your vendor. So work with them on that and see if that's potentially a solution for your needs. Now, some lessons learned for thermal aging. Obviously, thermal aging durations vary widely based upon the equipment type and the installed application. We've seen qualification durations for thermal aging last a month all the way up to 2 years. It depends on all the variables we discussed. So it's always best practice, get your harsh qualified components into procurement sooner rather than later to give your vendor the time necessary to get you that item. Best practice is always to run multiple test specimens. That's something that's standard practice here at Paragon. We always run multiple test specimens that have a means for justification in case there's any anomalous behavior notated throughout that program. It's definitely something that you want to incorporate into your programs. Reduce unnecessary conservatism and aging duration with the Arrhenius calculation. That's where we talked about the heat rise paired with the appropriate activation energies for your non-metallic materials. And then mitigating the risk of failure due to elevated oven temperatures that could be handled with parallel aging. So similar to what we discussed above, if you have an item that looks to be susceptible to elevated aging temperatures, we'll actually take backup test specimens, run them at a lower temperature to have a fallback and safety net in case there's a failure induced by that temperature that's not indicative of the application. So, you know, I can't speak to the effects of risk mitigation enough in harsh qualification, especially. So any technique that you can apply to your program to provide some safety nets and means to continue with schedule without large impacts is of huge value. Post-thermal aging, you're going to perform your baseline functional test, and you're going to move straight into the irradiation aging portion of your qualification program. You are essentially showing that your equipment can withstand the radiation environment while maintaining safety function throughout the entire qualified life, encompassing both normal and accident conditions. There's two categories that can be taken here. And what you're looking at is either a full harsh program or what's called a rad harsh environment program. If you evaluate your environmental parameters whenever you're establishing mild versus harsh environment, if radiation is the only elevated environmental parameter, you can take that and you can evaluate it against known industry thresholds as acceptable while avoiding a testing program to save cost and schedule. I have some thresholds here that I pulled from EPRI 2129. It's relevant industry guidance, it's widely accepted, and you can use these as thresholds for different types of equipment to avoid that unnecessary cost. If you're looking at unhardened electronics such as CMOS, NMOS, MOSFET, you have a radiation threshold of 1E3 rads gamma. So if you're below that 1E3 level, you can actually evaluate that as acceptable through evaluation only, no testing required. Similarly, if you have unhardened electronics such as transistors, operational amplifiers, resistors, capacitors, etc., you're looking at 1E4 rads gamma. Same with non-metallic materials, including Teflon. If there's no Teflon included, you bump up to 1E5. So that's a fairly decent radiation threshold to be able to evaluate a lot of different materials and constrain your program to evaluation only. If you're talking about a full harsh qualification program, radiation testing is going to be required, and that'll likely be handled with a third-party testing facility. What you're looking at there is for your vendor to envelope not only your total integrated dose, but make sure they're capturing the dose rate associated with your intended application, including additional margin required by your industry standards. So again, that's going to envelope both normal and accident conditions, and you're going to be working with a third-party facility to provide an envelope of all conditions applicable for your installed location. Lessons learned and some things to think about with the radiation testing: both dose rate and total integrated dose do introduce a potential failure mechanism to your equipment, especially with electronic equipment is especially susceptible to dose rate failures. So work with your vendor, make sure you're enveloping your requirement, but you don't want to overshoot or have excess conservatism that's going to drive a failure that is not representative of the installed application. It's a similar theme throughout all qualification activities. You want to simulate the installed application and balance qualification schedule needs versus meeting your requirements and avoiding failures, impact schedule, excess costs, etc. For programs with long aging durations or expensive equipment, you have the potential to monitor the equipment during radiation with particular and certain labs. So if your vendor has an approved lab on their AVL, approved vendors list, there are labs that perform 24-hour live monitoring of equipment functionality throughout the radiation program, which serves to benefit you in a number of different ways. If you've spent months and months or even years on a thermal aging program and you get to radiation and you send it to a radiation lab unmonitored, if you get to the end of your TID, you get it back to your vendor's facility, you perform baseline functional testing and there's a failure, you do not know where that failure threshold is for continuation with backup test specimens. If you send it to a lab that can monitor performance during radiation, you can actually verify at what radiation dose you started to induce that failure based upon your thermoluminescent dosimeters that your lab's using. They read those back, you compare that to your output of your instrument, and you have an effective threshold to take a backup test specimen up to that threshold and continue testing without having to restart a potentially long aging program. Having multiple approved radiation labs is critical. That's for a number of reasons. Each lab has different capabilities, different room types, different total integrated dose and dose rate capabilities. So it's important to have enough labs to cover whatever application requirement you might be trying to simulate in the field. Packaging and reduction of handling is critical. Again, we discussed it previously during baseline functional testing. You must remove any unnecessary failures due to overhandling of the equipment or impact during transport. So those processes and procedures are of just utmost importance. The third step in any aging program, depending on your equipment type, is going to be mechanical and electrical aging. It's a critical step. It's fairly straightforward. We're not going to go into a whole lot of detail here. It's important to know the number of expected cycles that you're going to experience in the installed application. If you don't know that number, there is industry guidance such as IEEE 649 that can help guide you in the right direction, so your vendor can envelope the requirement and get you a qualified item for the number of cycles you can expect over its qualified life. You're going to be looking to define what a cycle is, whether that's cycling of a contact, whether it's rotary or linear motion of an actuator. You define what the cycle is, you monitor the cycles, the cycle rate, and you always want to simulate the installed configuration, input parameters, voltage, amperage, all inputs to be able to make sure you're simulating the correct application for your qualification program. That wraps up the aging portion of qualification activities for a harsh program. I'm not going to go through seismic testing again. This is a portion of qualification testing in a harsh program where seismic is going to fall, along with the appropriate baseline functional testing. And there are no additional requirements for harsh application seismic testing versus mild. They're both performed in the same manner. So you're going to go through that seismic process. You're going to go through the baseline functional test, and all of that's going to bring you to the final step of your harsh qualification program, which is accident testing. It's an extremely important step. Your test specimen is at end of life conditions, in the most conservative conditions, the most amount of material degradation from all the previous parameters that it's been exposed to. And you're going to simulate your LOCA, loss of coolant accident, high energy line break, whether there's inventory remaining in RCS, the event causes superheat, you have a main steam line break, other high energy line breaks, whatever accident conditions are applicable to where that equipment is installed, you're going to combine and envelope all of that with your vendor to be able to get you the qualified item you need. What you should be looking at during this process is getting the correct environmental parameters for your application. So you're going to need your temperature and pressure profiles over the full duration of your accident. You're going to need humidity requirements. You're going to need your chemical spray requirements, all in relation to time and any post-accident aging requirements you may have. Your vendor is going to put together a profile to be able to envelope all those parameters, and they're going to install your test specimen in a chamber capable of meeting those environmental parameters to simulate the actual event in the field. I know at Paragon, we have some pretty unbelievable LOCA and HELB testing fixtures. Our system's really just top of the line. We can get saturated steam, superheat conditions up to 450 degrees F+. If we need to go higher than that, we absolutely can. We can meet any chemical spray condition requirements. We have 2 separate chemical spray chambers, so we can get your pH and chemical requirements met for different portions of the aging program throughout accident. We have separate environmental chambers to go into directly after the accident program for post-accident aging. So work with your vendor. It's of the utmost importance to make sure that your chamber is built as appropriate for your piece of equipment. The sizing, volume, all the capabilities are critical to make sure that you stick as close to the actual profile requirements as possible without overshoot that could cause a failure at the very end of your program. I know internally we have nearly 12 LOCA chambers that we utilize currently. And on top of that, for any application that requires custom development of a LOCA chamber, that's something that we perform standard practice to make sure that we're simulating these conditions appropriately. So after you complete this accident testing, you're going to be at your final baseline functional test. You're going to make sure that the equipment can maintain its safety function during and after this event. And once all that's wrapped up, your vendor is going to put together a qualification report detailing all of your test data, all of the occurrences notated throughout the program, and any traceability requirements to be able to tie future procurement orders to this qualification report. So that really wraps up the environmental portion of qualification activities. One other area I wanted to get into that's a bit separate, but still related to qualification, is electromagnetic compatibility testing. If you have EMC requirements for your application, it's important to know what standards and what tests are required for your application to make sure it's qualified for the correct parameters. I have all the tests listed here. We actually have an EMC test lab in-house. We're compliant with Reg Guide 1.180, EPRI TR 102323, and associated MIL standards, IEC, emissions and susceptibility immunity. And for any EMC testing that we can't perform in-house or don't have the ability, we certainly have an approved third party on our AVL to get that done for us to meet your application needs. Things to think about when you're talking EMC, modifications are common practice to be able to get a qualified piece of equipment. And it behooves and is of extreme value to perform those modifications up front to ensure you're going to have acceptable results, especially when it comes to emissions and susceptibility. So work with your vendor, talk about modifications, evaluate what you're testing against the requirements, and come up with a program that's going to get you the qualification you need. Now, moving completely separate from qualification activities, we wanted to talk a bit about verification and validation. Verification and validation provides the necessary data and input to dedicate safety-related digital equipment. The reason we want to include this here is because it's extremely beneficial and best practice to always make sure that you're verifying V&V with your OEM upfront prior to performing qualification activities. It's a huge risk mitigation technique. You want to make sure that the OEM has the capabilities, processes, and controls in place for your vendor to be able to dedicate that software and digital equipment prior to going down a long road, a long schedule, and all the costs associated with a qualification program. So whenever you're going through V&V, it's important to place priority on that to get it done upfront, ahead of qualification, knock it out, make sure that you're going to have a piece of equipment that's acceptable for you. After going through all the testing associated with qualification, I wanted to discuss some things to think about while you're procuring qualified items that we didn't touch on in previous slides. Some of those items that you want to be thinking about is number one, qualification is completely separate from dedication. You need to establish, does that item require mild or harsh EQ? It's going to dictate how you go to your vendor with an RFQ and what kind of program they're going to develop for you to be able to have a program giving you the equipment that you need for the application requirements. Is the item traceable to an existing report? Before you go down the road of looking into all the qualification testing that we just discussed, verify whether or not the item you have is previously qualified. If it's to a Paragon report and we're your vendor, we have the processes controls in place. That's an extremely simple process to establish traceability to that previous qualification report and get you a qualified piece of equipment without doing any additional testing. If you have a report, for example, an old Wiley report that's not of your vendors, still discuss it with them. There's the potential that they can still provide traceability to that report, given it has the necessary information to verify that traceability. So if you have an old report, don't go through the whole process of new testing until you talk to your vendor to see if they have that potential to evaluate that for you. If they do not, EQ testing is your methodology you're going to go down, and that's what you're going to execute throughout the program. If harsh EQ is required, schedule is an unknown variable, and it could take a significant amount of time. That goes straight back to the thermal aging that we discussed and all the input parameters required to make that happen. The information that your vendor is going to require, if you're performing a seismic only qualification, we're going to need your required response spectra. We're going to need your associated parameters, whether it be amplification factor, damping values, etc., and the installed configuration. If you're performing a harsh EQ, we're going to need your desired qualified life, all the environmental parameters that we discussed, temperature, pressure, humidity, accident conditions, your RRS and associated parameters, and the installed configuration. All that's going to be simulated throughout the program. And the final step that you want to think about is define your documentation review and testing hold and witness points. I know for us, we love working with everybody in the industry. If you want to review those QPs and QRs, qualification documents, certainly let us know. If you want to witness testing, we certainly welcome you. You know, the more interaction, the better, and we can get you the qualified item that you're going to need. Looking back at all the experience that we've had with equipment qualification, it's important to note, you know, Paragon has supplied over 12,000 projects requiring equipment qualification. We have EQ experts who are knowledgeable with the details of specific standards. We've been involved with EPRI and the NRC in developing important EQ industry criteria and guidance. And our procedures and techniques help maintain schedule and avoid costly failures, which drives straight back to the huge need for risk mitigation techniques when you're talking about qualification. I can't stress it enough. It is the largest contributing factor to reducing failures and reducing impact to schedule if you have the appropriate measures in place to mitigate that risk. Our EQ reports are all inclusive and remain available. That goes back to traceability. You want to have clean reports with all of the documentation clean, clear, understandable. Anybody can pick it up and do a traceability evaluation for future orders. It's something that we place extremely high priority on, and Paragon provides nuclear equipment qualification technical support for any variety of application. Whatever your needs are, reach out to us and let's work together on that. Now I wanted to turn it over to discuss our PEAKS application a bit. Ty, I'm going to let you take this over, and we'll go from there.
All right, Ross. Well, great job, man. Thanks for all that technical detail. At Paragon, we strive every day to try to make life easier for you guys working at power plants and at DOE and DoD facilities, as well as the people that are trying to design, the next generation of reactors. And one of the ways that we do that is through the use of data, and we've expanded our data to include all of the qualification information that we have on those 12,000 plus items that we qualified at Paragon. We've put all of that information now in our public catalog called Peaks. So if you go in and you search for, let's say like this example, which is a breaker, a pretty common breaker at nuclear power plants, you can actually see whether or not that part has been qualified before. And as Ross alluded to, several times during the presentation, we want to make one of the ways that you're going to mitigate your risk is looking to see if a part has already been qualified before. Certainly something that's been through the qualification process gives you, if you have to maybe extend the qualification or go and have it qualified against a higher spectra on seismic qualification, you can look here and say, okay, well, I know it's been qualified once, so the likelihood that it's going to be able to be qualified again is pretty high. And that's the power that we've got here with Peaks. You can also see a lot of other information if you haven't ever used it. You can see all of the material that's in stock at different places at Paragon or in stock in overstock situations at utilities. And you can ask for help on our online forums, either through the chat or requesting a quote. And somebody's there to talk to you 24 hours a day, 7 days a week. In fact, they're just in the office next door to me. I can hear them talking to somebody right now that's in outage. So we got 19 plants down, I think, right now. So a lot of work going on here at Paragon. So with that, I'd invite you to join Peaks and look at it and see how that could meet your needs. So let's talk a little bit about some key takeaways from this presentation today. We talked quite a bit about risk mitigation. That's a critical aspect of environmental qualification. We want to make sure that your testing is successful, and we go through a lot of different processes to make sure that your risks are effectively mitigated when you come to Paragon. It is an intricate process. There's a lot of different ways that we can meet your needs. There's a lot of different tests available, different tables that we can test on, different radiation vendors, depending on whether you need a high dose rate or a lower dose rate. We can take care of all of that. Schedule is a really important part of environmental qualification. Sometimes things can take 2 years to complete testing. So we want to be collaborative with you. We want to make sure that you have the right information when you're thinking about your environmental qualification projects, and that you don't get in a bind. And as Ross alluded to, we have some parallel path methodologies that we use to try to make sure that you've got some ways to install equipment and not get into a bind in the future. And again, we want you to work closely with your vendors to develop the process that works for you. And we try to make that collaborative here to make sure that we're meeting all of your needs. So with those takeaways, let's move into some good questions and answers. So we've got 7 questions already, which I always get really excited about. So feel free to keep asking them. And Ross, I'll do some translation for you, but you're going to have to answer them because I don't generally know the answers to these questions. So the first one, I see one from Ed here. He's talking specifically about aging. He says, is there a need to select temperatures such that the surface temperature and the aging temperature do not have different activation energies or cross a material phase change? How do we deal with that, Ross? Do you know?
So yeah, we always select our activation energies based upon the material of construction and that material's function within the piece of equipment. So it's absolutely necessary. You have to look at your activation energies, how they were developed, to really define and set the correct activation energy for the material within your application. So that's absolutely something that you have to think about whenever you're developing that process.
All right, great. And what about in radiation aging? So how do we address beta radiation in total integrated dose?
So a lot of times beta radiation is written off mainly due to the nature of beta radiation and the high level of attenuation that typical equipment casing provides. Beta radiation oftentimes does not pose a significant failure mechanism for equipment, especially if it's installed in some type of enclosure, cabinet, casing on the equipment. So for the most part, your testing and testing methodology is going to incorporate gamma radiation testing only.
Okay, thank you. Here's a good question from Ron Weiss. And I've also made Jeff Stubblefield a panelist with us, so he can help us answer any questions, Ross, if you need him to. So
Sure.
And Ron asked, can we discuss our experience with radiation testing of digital equipment? In particular, do we have any experience with conducting radiation exposure while monitoring the performance or output of a digital device so that we can detect any intermittent or self-healing effects on performance while the specimen is in the radiation field?
Absolutely.
Okay.
So we do have a radiation lab on our AVL approved vendors list that can handle 24-hour monitoring of equipment performance. And we've been through a large number of qualifications, especially with digital transmitters, whether we're monitoring a 4 to 20 milliamp output, whatever equipment type it may be, and we're looking for deviations in performance live, real time during the irradiation process. So that's something that's been critical for us on a number of projects, especially with digital equipment. So it's definitely something to work with your vendor on, work with us on, and we can make that happen for you so you can see any drift in operation throughout that program.
Great. So this is a question once we get into kind of the accident conditions. So in an accident test, do we have to introduce oxygen back into the test chamber, or how do we simulate the actual plant conditions where there's some oxidizing environment?
So yeah, it's case by case basis. The accident conditions applicable to a given environmental program is going to be specific based upon where it's installed, all the application conditions, and that goes back to the environmental parameters associated with that installed configuration. So no matter what you have, we are going to simulate that because it needs to be simulated during accident conditions. So if you have reintroduction of oxygen, if you have any sort of event that needs to occur, we'll increase that oxygen level, seal back up the LOCA chamber. If there's any sort of temperature variations and temperature heating and cooling effects that need to be accounted for, any accident condition parameter, that's what we're going to simulate during the program. So it's important to give that information to your vendor and include that in the profile as application requirements.
Great. All right, great. What about the difference between aging in a static versus a convection environment? Do we need to move to a convection oven versus a static oven to address actual plant conditions?
So yeah, we actually have a large variety of ovens in the back, and depending on the size, equipment type, and aging duration, we have ovens selected to be able to simulate and provide constant temperature input that's monitored through a data acquisition system to make sure we're holding that to simulate the installed environment. So it's important to make sure your vendor, and you can ask them for this data, and we often include the raw data in our program to see temperature versus time for the oven that equipment's installed in. Absolutely.
Great. Just here, going through some questions. So Ron has another question. So do we have any thoughts or comments regarding environmental qualification of active mechanical equipment per the ASME QME-1?
I'm not particularly familiar with that standard off the top of my head. It's certainly something that we can look into. Jeff, I'm not sure if you're familiar, but regardless of the industry standards and requirements that we're going to perform it to, we're going to use these methodologies in accordance with those requirements to envelope your application requirements.
So Ross, we actually have, and it just depends on which year, because there's a couple different code years for the QME ones. We've performed those qualifications for some valve manufacturers on their actual valves themselves. So it is a little bit different program than your traditional IEEE 344s and 323s, but we do have experience in qualifying to the QME1 programs.
Perfect.
All right. Thanks, John Portillo. I hadn't introduced you yet, but John Portillo is also on the line. He's a long-term employee of Nuclear Logistics, now Paragon, and a lot of experience. So thanks, John, for jumping in there. So a question about peaks, I'll try to answer it, but if I can, I might have to get some help. So could peaks be leveraged to dedicate, certify a new lot of similar relays to an existing qualification report at a reduced cost, rather than performing a completely new test? Would that be an application of peaks? So I think the question is coming from Coulter, Somerville. Could we use a part from maybe from an existing power plant that has do a similarity evaluation against a part that's coming out of inventory at a plant, and maybe to some other parts that are in existing inventory or in inventory at other plants. And we've tried that, Coulter, a couple of times with some different utilities. I think that it's something that we don't do a lot of because environmental qualification tends to be something that we would really like to establish traceability back to an original specimen, so that you don't get a accumulation of errors. That's what I think the biggest concern is when we're doing that. But it is certainly something that we've looked at, that we've done a little bit of here, and something that we would investigate if we're able to do that more often. The power plants in general are a little hesitant, just because there's some ways to introduce some unknowns, and in particular, is there maybe something about that qualification specimen, and then the similarity analysis that went for the equipment that's installed in the plant, and then you get that third or fourth generation removed from that sample, you do have a risk of some unknowns kind of creeping back into the similarity analysis.
Ty, I'm going to take a little bit different approach to that question.
Sure.
Because the way I'm reading it, it kind of sounds like they're wanting to know if they look at peaks and like you just showed, and it shows that it's been qualified, and if they're going to get a new lot from purchase. So say I'm going to go buy those HMCP breakers brand new, buy a lot of them. Can I use the existing qualification report to save time and money? And the answer to that question is 100% yes. That's exactly what we want to use it for. Because if you're going to buy, say, because we will then trace it back to the original qualification report, we'll buy 11 circuit breakers if you need 10. And as Ross had said earlier, we'll take a random one out of that lot of 11, and we'll do all of the material testing to ensure that it's traceable and it's the same material that's on the original qualification report, traceable to the original qualification test specimen. So you will save all of the expense of of performing a new qualification program if everything is similar.
Yeah, I think John, good catch. I think that is a better answer to that question. So Coulter, we can certainly leverage peaks to do exactly what John is talking about, and you should be looking at it as well. So if you see a part that's in there that's already qualified and it's something that's sitting on your desk that you need to address, we can take advantage of that existing intellectual property. So that's a good way to save money. And that's one of the reasons we moved all that information into peaks, is to help do exactly what you're asking about. So we have another question. This is on the seismic table, and I see some other questions coming in across the chat that we'll also address. So you can use either one. You can either use the Q&A button or the chat function. Both of them work just as well for us. This one comes from Damjong Bizak. I probably just butchered that name. I apologize in advance. But is it acceptable for a one-axis seismic table to perform IEEE 344 seismic testing, or is it a minimum necessary for a biaxial seismic testing? So could you use just a single axis, or do you need a biax to be successful?
Certainly. So we don't utilize single axis testing in our facility. However, I believe there are guidelines for uniaxial testing and the associated requirements for that testing. So I believe the answer to that question is yes.
Yeah, it seems like we've used some here in the past to do some resonance searching as well on a single
Right. We'll use our multi-frequency tables in one axis for different testing types, but we don't have a uniaxial table. Correct.
All right, let me check here in the chat. So
Ross, if we're using a single axle table to perform a 344 test, you're going to have to manipulate the test specimen in a multitude of different configurations, right? To get the actual.
Right. So similar if you're performing OBE testing, which is an aging mechanism on a triaxial table, you're doing that test a total of 5 times. If you're on a biaxial, you're rotating it in 0, 90, 270, and 360 degrees to be able to perform 20 tests to verify the same requirement. So the smaller number of axes you have, the more test runs you're going to have to do.
yeah, that's a great point. So one question we got coming out of the chat is, have we done any qualification of the Rosemont 351 transmitters for radiation? And if so, what is the TID limit? John, do you know if we've done the 351?
One moment, please. Go to the next question.
So another question, and Jeff answered it in the chat, but I think it'd be good to reiterate it on this. So for seismic qualification, are there any criteria for small valve gauge to use multi-frequency test instead of the rim test? And Jeff, you answered that in the chat, but you can just reiterate it here if you'd like.
Sure, absolutely. Can you hear me, Ty?
Yes, sir, I can hear you just fine.
Perfect. Yeah, the requirements of IEEE 382 are overly conservative, of course, due to the lengths of piping installed at plants and the variations therein. All depending on how long your piping is, your resonance frequency of that piping will change. For example, if you have piping that is shorter, it's going to have a higher natural frequency as compared to piping that is extremely long that has a lower resonance frequency. So having said that, we're able, if we know what the requirements, basically the response spectra at the device location, we certainly can get away from doing rim testing, which is an overly conservative test. So there are methods in place to do testing on equipment that is normally subjected to rim tests.
Well, thanks for that, Jeff. That's a good clarification.
And as for the Rosemount equipment, I know we've worked with Rosemount before. I don't know if we have any experience necessarily with radiation.
I have a qualification report for the 3051. I'm just looking to see if it's harsh or if it's mild.
Okay.
All right, we get to live use of all of our data tools here at Paragon, so they're really helpful for us. Any other questions or anything from the audience? We're coming up on, we've been here together about an hour, but we'll stay as long as you guys have questions. Certainly if you've got other meetings to attend, we all know how that is. You can drop off, but you're welcome to hang on with us and we'll answer any questions that you've got for as long as you'll ask them. So. See if we get anything else here.
Sure, I'm going to open this. It's going to be a 400-page report. So.
Oh, that happens. That definitely happens. So Ross, before you were joined Paragon, did you know what equipment qualification was at all, or did you just become interested in it once you got here?
Yeah, absolutely. I was thrown into equipment qualification on my very first project back when we were in LI. So about 10 years ago, ever since that project, it's been a passion of mine. So I've been through all different equipment types, all different industry requirements, all different types of harsh and mild environment programs. And we have a number of other engineers here that have been involved with qualification activities for most of their careers. So it's really, really a strong passion within the organization, not just myself.
Yeah, so I've got a couple other questions that have come in. So one is from Thomas out there in Europe. So thanks, Thomas, for joining. I know it's getting late there. He asked about getting the presentation. So if you'd like a copy of this presentation, just shoot me an email. I'm the guy, Ty Smith, that sent out all the invitations for this webinar, and or send me something in the chat or on a question, and I'll be happy to send you this this presentation so that you'll have it for your records. And we got one more question coming in. So what software do we use to generate the TRS, RRS, and time history?
So I can go ahead and answer that one if you don't mind, Ross.
Sure.
Depending on the seismic shaker table, it depends. For our biaxial shaker table, we generated our own in-house developed software back in the mid-90s, early to mid-90s, and have successfully done verification, validation on that software. Recently, I say recently, maybe about 5 years ago, the source code was slightly rewritten to make it more user-friendly. But that in-house developed software has many years of experience and validation and is commercially proven with other seismic shaker table software. Now, on our large triax, our 10-foot by 10-foot triax table, the source code was, a majority of the source code was developed outside of our company by a third-party service provider. And we did the IV&V, the independent verification and validation on that safety-related software. So that's a commercially proven software program as well. There's various other smaller programs that were written either in-house or by third parties in order to basically take that RRS, make a time history file from that, a random time history file, and then to take the test response time history data and convert it back via fast Fourier transform. That's all combined in the software, and we have V&V reports for each of those equipment models.
All right. Well, thanks for that.
So
Jeff.
on the Rosemont, I'm sorry, but it was seismic qualification only.
Yeah. Okay. Well, Kristen, that's the best answer we've got for you right now. But I know that there's quite a bit of experience with the 3051, so we'll reach out with you to you directly and see if we can help with your specific questions and your specific application. A couple more answers or questions in the chat. So,
Carlos, I have this email from you right now, and I'm already working on this question.
Okay, good. Good.
You can go read it, Ty.
Yeah, we're working. It's working. So, Carlos, who works with us down in Mexico, is asking about, how do we take a safety relay component in stock and sell it to another nuclear power plant that doesn't accept 10 CFR 21 responsibility? And then really what we do is what's called a document review. It is a form of dedication in our facilities. We take that component as non-safety related from the power plant. We take a document package. We do a receipt inspection, do all of that work on it, and then we will put it through our safety related process and take Part 21 responsibility for it ourselves. So if you're buying a part through Peaks and the selling utility does not have a Part 21 responsibility, we can take that and do that through Paragon.
Now, to follow up a little bit on that also, because some of the ones that we've been running into, they also want us to take responsibility, or at least verify the harsh environment qualification is still maintained. So that's part of the document review, and that is going to come down to what documentation the plant has on hand for us to review. Yeah,
good point, John. One question from Scott is, what's the difference in stock versus overstock in Peaks? So something that's in stock, Scott, in our Peaks program, when you look at that, if it says it's in stock, that means we physically have that component at Paragon in one of our warehouses. So we can ship it to you same day. That's the difference. If something is in overstock, that means that it's sitting at a utility and maybe it's at a above max level and it does not have any current demand against it. Then it's likely that utility will release that part and sell it to another utility through our rapid response program. So we list that as being basically likely for sale from a utility, but it is not in any of our warehouses for sale. Edward is asking about the email address where we can ask for the presentation slides. You can send an email to the address that's listed here on this slide, info@paragones.com. Just a little behind the scenes look. I get all those emails along with Matt Schustrick and Keith Porter. So we are the people that receive all the info at paragones.com emails, and one of us is always on top of it. It's usually me, but Matt and Keith are catching up, so that's good. Thomas out in Europe, I think it's Sweden. Is that right, John?
Yeah, Switzerland.
Switzerland. So he's asking if we are able to help him extend the qualified life of installed components for from 40 years going to 50 and going to 60. And Ross, I think the answer to that question is yes. I know that we've worked with you guys and others in the past to do that, but just confirm that Ross, that we're able to do so.
Sure. Yeah, so absolutely. That's something where if you have the original qualification reports that your equipment is qualified to, you can supply that to us. We can evaluate it for both temperature and radiation mainly, and we'll see if there's any variables we can modulate based upon real life occurrences and parameters. And we'll see if we can actually extend that qualified life. So if that's something you want to work with us on, that's definitely something that we can look into and handle.
Yeah, so Tom,
Yeah, absolutely. To ping on that, whenever we do an aging program, we do it to typically the maximum number of cycles and the maximum postulated normal temperature. So if we find out that your actual room temperature in that location is an average of like 70 degrees Fahrenheit or 75 degrees Fahrenheit, where we actually age it at 90 degrees Fahrenheit, we can basically give you an extension on that qualified life. That's
exactly, Jeff. And
that's why we need every article of information from the plant, including actual in-cabinet temperature and actual cycle count.
Right.
That's the key, is the plant have the information for us to do.
Correct.
That. Right. But Thomas, I'd be happy to come out to Switzerland and help you find all that information. I enjoy the KKL plants.
That's right. So one of the questions coming from Kristen here in the chat, they ask, what's the difference between re-engineering and reverse engineering? And that's a really good question. I'll do my best to answer it. It's somewhat nuanced. It's really a question about how you define reverse engineering versus re-engineering. In the way that the Paragon kind of handles things, very few parts that are from a nuclear power plant, let's say a drawer or something like that we're reverse engineering, quote unquote. Very few of those things are a true 100% reverse engineering, meaning that there is that every single component is still available, that everything's going to be exactly the same. Almost no project ever goes that way. So there is a component of reverse engineering that is always some re-engineering at work. So you may be redesigning a DC to DC converter, for example, in a drawer, and functionally that drawer is all the same, and it's primarily 90% reverse engineered from its original drawers, but there are a few components that are no longer available. We've also upgraded some drawers to things like TDL logic, because we weren't able to get some of the other ways that the drawers or electronics used to operate any longer. Another thing to think about, Kristen, when we're doing the re-engineering versus reverse engineering, when we take something and do a black box approach, that is primarily a 100% re-engineered item. The exterior really looks the same. The inputs and outputs are validated to be the same, but the way that you go from an input to an output can be completely different in those components. And so that's really a re-engineered, or what we also call a black box approach to what we reverse engineering. So there's a little nuance there. I hope it's not too difficult to kind of think through, but I think of it as reverse engineering is trying to keep as much of that component the same as possible. I think what's important to nuclear power plants is that is the human machine interface staying the same? That seems to be really critical. And also your failure modes roughly the same. And if they're not, You need to make sure that the vendor is providing you, all your item equivalency reports and updating the failure modes and effects analysis so that the plants can evaluate that and see if anything is impacted in their safety analysis. So let's see. Oh, there's an attendee that says, is the correct email address Paragon ES or Paragon EES? So I appreciate that question, and I assure you that the ParagonES.com is the correct one. And if there is a typo in that flyer, we'll make sure we get it corrected for next time. So thanks for finding that. Another question from Thomas. So when extending qualified life of component, like a limit switch, for example, use the actual room temperature, et cetera, is the original seismic test still valid after recalculation of qualified life?
Yes. So
Yeah. Okay.
Yeah, because we simulated a condition that was indicative of the information presented at that time. Whenever we're reevaluating to the extended qualified life, we're shifting parameters, but the condition of the age specimen remains the same. So whenever you're talking about that, whenever we look at all the environmental parameters to be able to extend that life, the previous seismic qualification still stands valid for that application.
So basically, it became an overqualified condition.
Exactly.
All right. Well, I don't see any other questions. We'll give it just another couple minutes here to make sure we're ready. So we do appreciate everybody attending with us, and I hope you guys got a lot out of it. Ross, you did a great job. Thanks for taking the bull by the horns and putting together engaging content on this somewhat complex topic. It's certainly something
I appreciate the opportunity.
Yeah, it was really well done. So I don't see any other questions coming in. If you guys have any questions, we'll be sending out a follow-up email to all the attendees, making sure you've got that link. You can respond to any of those with a question. We'll be happy to answer any questions you have or to help you think through your environmental qualification programs, any issues you've got with your parts. So maybe you've got something that's been sitting on your desk for a while, you're not sure what to do with. Paragon specializes in those kind of situations where you just can't quite find an easy answer. We're here to help you get through that. So again, I appreciate everybody's attendance today. We really are thankful for you to spend that time with us, and we'll let you guys go and get back to making sure we've all got reliable, clean power. So thanks very much. Goodbye.
Very much, everybody.